Okay, we have more examples here. This is for chapter 3. We have a pressure gauge connected to a tank which reads 500 kilopascal at a location where the atmospheric pressure is 94 kilopascal. So the main point I want you to see in this part is the concept of absolute pressure and gauge pressure. So as you can see in this slide, we have the tank. We have the tank, and a gauge is attached to the tank, and the gauge reads 500 kilopascal, and this 500 kilopascal is the gauge pressure. That is the gauge pressure. So let me make a correction here. This is P absolute is equal to P atmosphere plus P gauge. So that is gauge pressure. So we are told that the reading is 500 kilopascal, and we are told that the atmospheric pressure at that point is 94 kilopascal. So the absolute pressure inside the tank would be 594 kilopascal. We also have another example here, but you can look at it. It's very simple, and you can work on it or on your own. The only difference is that the unit that we're using here is the English unit. Another example we have is that of a water tank. The water in a tank is pressurized by air, and the pressure is measured by a multi-fluid manometer as shown in the figure below. And we're asked to determine the gauge pressure of air in the tank if H1 is equal to 0.2, H2 is equal to 0.3, and H3 is equal to 0.46. And we're given the densities of water, oil, and mercury. So you can see the arrangement of the tank you have. So you have air in the upper part of the tank, and you have water, and you have the multi-fluid manometer on one side. So I hope this is visible. So this is what we are gonna do. You can see point 1. You can see point 1 over here, and point 2 here, and we're going to connect the two points, and we are going to see how pressure varies as we go from point 1 to point 2. Not only that, we have intermediate points at the end of H1, at the end of H2, and at the end of H3, which actually is going to be point 2. So you can see over here on top the equation that we will get. So you have pressure 1, that is the pressure at point 1, and as you go to the next point, which is the next level, that will be a pressure increase of a value rho gh. So P1 plus, since we are going downwards, we have P1 plus rho 1 gh1. And when we continue to the next point, we still have a point here which is lower than point 1 here. So we're gonna have plus rho 2 gh2. And the next point, when we go to point 2 here, we actually move up, so we have a drop in the pressure, so that will be minus rho 3 GH3, and that will be equal to the pressure at point 2. Now point 2 is exposed to the atmosphere, and we are asked to determine the gauge pressure, so all our analysis can be in terms of gauge pressure. And when that is the case, since P2 is equal to P atmosphere, then P2 will actually be 0. So that is what you see in the analysis here. So P1 gauge plus rho 1 GH1 plus rho 2 GH2 minus rho 3 GH3 would be equal to P2 gauge, which is actually equal to 0. So as we continue and further analysis, you will have this, and rearranging the equation, you will have P1 gauge equal to rho 3 GH3 minus rho 1 GH1 plus rho 2 GH2. So after inserting the values, you will get a pressure of 55.77 kilopascal. Okay, so we have discussed many things so far in part 1 of chapter 2. Before I discuss the next two slides, this slide and this next slide, I want to ask you some things, and I want to hear your reflection on these. So we have said, if we have such a tank, uh, and the above surface is exposed to the atmosphere, right at the top we'll have atmospheric pressure, and as we go down we will have the pressure increasing. Now in this case we have a layer of fluids. We have 3 fluids, as you can see here. So I want to ask you, how will be the pressure distribution? We have seen in the second part of chapter 3's review how the pressure distribution will be in a certain fluid. So if the fluids vary, if we have 3 fluids as in this case, how will the pressure vary? So show the pressure distribution for this case. So show the pressure distribution, and you can send it, you can attach it, send it as a message, as a private message in our Google Classroom. Okay, and the second one is, here we have a flow section, and we have point 1 and point 2, and between the two we have a manometer. We have a manometer attached to them, and we have a fluid here, another fluid that we use to measure the pressure. So just see what kind of equation you will have for the pressure, just like we did for the water tank. So start from point 1 and then trace to point 2 and come up with the equation, and it's gonna be a very simple equation which you will relate to later on. So please check these two and send your thoughts, your questions, or your answers directly to the Google Classroom. Send them as a private message in this attachment.